in real world, if you collect the data set, you don't really know what the real relationship is, right? But here we do want to, because we want to demonstrate the idea of overfitting and underfitting issue, so we create this relationship. We do know the relationship, and then we generate the data based on that. Okay. So a typical underfitting issue is like this. The real relationship is a quadratic relationship, but you try to learn it with a linear model. So because the linear model is only capable of learning the linear trend, so this will be our linear model, which does figure out that if you increase x, it seems that the y also increases. That's what your model can learn, right? But your model is going to miss the bending here because the linear model doesn't learn the curvature. So your model is likely to underestimate on this part and overestimate for this part. And that is the case. The problem is actually from the model. You have a too simple a model. So in this case, even if you generate more data set and provide a bigger data set to your model, it wouldn't help the accuracy of your model. Seems that there's a question. Oh, there's a question. How do we know when we are overfitting on the fitting issue? Well, so the thing is we have to first understand the overfitting on the fitting issue, and then we will discuss how we could detect it. Essentially, we're going to use the learning curve to compare the performance of training data set and the test data set to figure that out. And let's get back to our definition or description of on the fitting issue. So again, our model will miss important pattern because it is too simple. And if that is the case, it doesn't matter how many more observations you provide to your model, it will always miss this pattern. An overfitting issue, on the other hand, is when your model is too flexible. So if we, instead of using a very simple linear regression model, try to fit a model, a polynomial of degree 1 to the data set, we might want to use more complicated one. So for example, we're going to do a polynomial regression, and we want to fit a polynomial of degree 20 onto this data set. So if you raise the degree of polynomial, then what happens is this curve, the graph of the function, can bend a lot. It turns a lot. And in that case, your models will learn all the random fluctuation. So besides this main relationship, this main quadratic relationship, your model will also learn, hey, it is a little bit higher here, it's a little bit lower here, and all those random fluctuation because of noise will be also captured by your model. So in that case, what your model will learn is very specific for this data set. If you generate a new data set based on the same relationship, that quadratic relationship, then the random noise is random. So it might not be, again, getting higher here, a bit lower here. It will be different. So when you try to predict on that data set, your model is not going to perform very well. And also, if you just generate more and more data set and fit them to your model, your model is going to learn different pattern. So your model is going to learn different information. The variance is going to get higher. So that's an issue, the overfitting issue and underfitting issue. Is there any question about those? All right. So if we're okay with the definition of overfitting and underfitting, let's take a look at how we could detect those issues from a data set. So to understand or visualize this bias and variance trade-off, the trade-off is actually from the flexibility you give to your model. So you wouldn't be able to solve the underfitting issue and the overfitting issue at the same time because it's really attached to how flexible you allow your model be.